Hey, back again at Ramsey Land. Rick Crosslin here, and I understand you guys have been studying about electromagnetic fields and magnets. I love electromagnetic because my hero, Michael Faraday, a British scientist, studied magnets, and he actually was one of the first to document it. And I saw his notebook where he wrote drawings of lines of magnetic force. Now, this is a bad boy magnet. It's a big one right here. In fact, it's not as big as the Earth. The Earth is a giant magnet with North Pole and South Pole. But this magnet is very powerful, and instead of wearing my compass hat, I can show you, just getting it close to it is pretty strong. And so I'm going to put this out of the way. Watch out, because this could be dangerous. And that is a strong magnet. And so the Earth is a big magnet. But I brought some things today to talk about it. So Michael Faraday, he talked about these invisible lines of force. And so this is a cow magnet that farmers used to use. They would let their cows swallow this because back in the day, they would stay in their stomach. And anytime a cow would chew grass and maybe get a piece of wire in its stomach, instead of it tearing and killing the cow, this magnet would hold that piece of iron wire in its stomach, and its digestive juices would erode it and it would keep the cow from dying. But it's called a cow magnet. It's kind of cool. Wow. Now I think they use bales and big round bales, but let me put that in there. You see that those are iron filings, because a magnet will attract iron and other magnets. So there's filings. You don't see any pattern until I drop the cow magnet in it, and then you see a really cool three-dimensional magnetic field. In fact, I think you got one right here too. So and you notice that it's strongest at the poles. Magnets are strongest at the poles, both the north and the south. So that's kind of cool. You take out the magnet, the iron filings move about. So magnets, there's a lot to learn about magnets. Now, I hope you paid attention. They attract iron, and they also attract other magnets or repel. So I've set this guy up. Check this out. So that one's kind of, is that attracting or repelling, do you think?
Attracting.
Let's see, it's going towards it. Now if I flip this over, that's going to be opposite.
Repelling.
Now it's repelling. See if that's going to repel. That's repelling. In fact, if I get this going just right. Ooh. And you know, don't say it's magic, it's science. So that's kind of cool. Now if I flip them back over this way, now they should all start attracting, because I've changed the poles. I guess that's the strongest one right there. So that's kind of cool. Now magnets come from, naturally, this is a piece of magnetite. And magnetite is actually a mineral, a rock mineral, and I got some magnets right here, and they should stick to it. And it's kind of cool. So they're natural. Can you imagine if you were the first one to discover the properties of magnets? Because with a magnet, back in the day, if you were a ship or a sailor and you wanted to go somewhere and you couldn't see the land you're going to, but you knew it was straight, you could probably use the sun, but at night you could use the stars. But what if the fog or storms? You would be lost. But with a magnet or a compass, you could always go true north. And so magnets really helped a lot of navigation. But I got two more things to show you on this one. This one, I got some pieces here. Let's see. Here's my giant magnet. Let's see if I can do this right. Ready? This guy right here. And 1, 2, 3. Don't say magic. Science. That's kind of cool. Now, so you see a magnet here, and this must have iron in it, and I got a string going. So let's do some investigation. Make a prediction. Here's a piece of paper showing poles on a magnet. What's going to happen? Thumbs up or thumbs down when I do this? What do you think?
It's good. Thumbs up. I say probably strong. I say thumbs up because it's not as thick.
Oh, yeah. Let's make it thicker. Let's put a piece of so paper. Let's try wood. Yeah, you want to try some wood? Here's a piece of wood. Thick. Make a prediction. Thumbs up. Predict something. What do you want to predict? Thank you. Up. Get 1. Don't bang the table. That's a variable.
Whoa.
Oh. You know, let's go to plastic. In fact, I got 3 pieces of hard plastic. One's transparent, one's translucent, and one's opaque. Put them all 3 together. Quit banging the desk. You're killing me, man. 1, 2, 3. Predict.
Yeah.
You know what? Let's switch to some metals. So this is aluminum can, a metal. Predict. Here's a big piece of aluminum. It has it's thicker. It's thick aluminum. Predict. What? Another metal, copper. Predict.
No.
It's going to go down? Brass. Brass is an alloy. They're both congruent, same size, same shape, but this is much more dense. Feel this one. Feel how heavy that is. Which one's more dense? The brass? Let's try the brass. Thick brass. Ready? 3. Predict. 2, 1.
Yeah.
What? Here's my ring made out of gold from Egypt. It's got my wife's name on it and room for Tutankhamun, King Tut. Gold. What's going to happen? Ready? Predict.
Yes. No.
It stays, even with gold. And this is the last metal I have. This is lead. Don't ever touch lead because it gets in your body. It'll mess your brain up and you'll never get it out. This is malleable, thick lead. It protects Superman from, kryptonite. Ready? Predict. It's very heavy. Lead.
Yes.
3.
Yeah. No.
Yes. Predict. 3,
No.
2, 1.
Oh my gosh.
In fact, remember Michael Faraday and those invisible lines of force? I'm going to see if I can ruin this. Ready? Watch carefully. I cut the invisible lines of force.
Yeah.
Those are metal. This is metal.
Yeah,
This
but
is
all
metal.
the other metals that you were doing aren't magnetic, so it
What do you
wouldn't.
mean? What do you mean? Don't be so negative. What do you mean? So what must be in these scissors? Iron. So you mean if I just did that?
Yeah.
Yeah. So the iron interrupted. In fact, this might even work. I don't even need to cut it. Maybe if I go like this, what do you think is going to happen?
I don't think the other side's. I don't think the other side's. Oh, it is.
It is.
It's still going too.
It is still going.
Because it's the holes.
Magnet.
So what's the difference?
The difference is it's not cutting it, it's interrupting it. I got one more thing to show you, all right? Let's put this off to the side here. Okay. One more thing. This one though is kind of a, you guys are, this is a tough crowd, but very observant, very observant. We'll see, let's see how observant you are, okay? Take this big magnet, there we go. And so I have here a magnet. There's a magnet. Let me get this out of here. There's a magnet inside of here. See that? There's a magnet inside of there. There's 2 magnets in there. You're right. So here is a bolt. Ready? So here we go. Ready? So you have really been paying attention this time. So put that, go ahead and drop that bolt in there from about that, a little bit higher, a little bit higher. 1, 2, 3. Nice. That worked. That worked. And I don't know how much you've been paying attention. You've been paying attention? Huh? Go ahead and try that one, okay? Ready? Pick it up. Drop it from right about there. Same way she did. Really?
Ooh, I know what's happening.
I know why too.
What?
You switched it down.
I switched. Fine.
You lifted it up when he
I know
dropped it.
why. I know what happened. He's dropping it.
The wrong way?
Yes. Well, that.
Go ahead. Try it. You know, I don't really understand.
Switched it.
No, try it.
just switched
I
it.
switched it upside down. Try it. Don't be so negative. 1, 2, 3. See how she works that?
Because
Can we
you
do
had
it?
upside
Can we do it both
There's nothing in my hand. Now, be quiet, boy. Drop it in here. Come on. Don't sit back down here. Anyway. 1, 2. This class ought to be sent back to a different grade level. I don't know what to do. 1, 2, 3. Oh, yeah, there's something in there, and there's something that came out. You know,
You just took it out.
what it is.
You have it in your hand.
You know what?
He took it out.
I am going to find a classroom with more gullible students. So explain what's going on here.
What's going on?
I would say the other bolt isn't. It's iron.
There are 2
Well,
bolts in there.
there are 2 bolts, and I don't see 2 bolts in there.
Look at your hand.
Yeah, there's the bolt. Oh. So tell me about those bolts then.
What's the difference?
What's the difference?
One
One's heavy, one's not.
One has iron.
One's less dense and one has iron.
One less dense.
Say that again.
One is less dense.
One has more iron in it.
What's that?
One has more iron in it.
One has iron, and guess what? The other one is made out of aluminum. So let's see if you can drop it in there. So let's drop the iron one in first. I'm gonna have to give me another job. Drop the iron one in first.
Which one?
Drop the iron one in first. It sticks.
There you go.
Now drop the aluminum one.
There you go.
And that is a mini lesson on electromagnetism and kids who don't play along.